What is the equivalent of CCTT2 using the Crank Nicolson scheme for finite volume approach? A. Frac 1 2 CCT Frac 1 2 CCTT. B. CCT CCTT. C. CCT CCTT. D. Frac 1 2 CCT Frac 1 2 CCTT. The correct answer is Frac 1 2 CCT Frac 1 2 CCTT. What is the equivalent of CCTT2 using the second-order upwind Euler scheme for finite volume approach? A. Frac 3 2 CCT CCTT. B. CCT Frac 1 2 CCTT. C. Frac 3 2 CCT Frac 1 2 CCTT. D. Frac 1 2 CCT Frac 1 2 CCTT. The correct answer is Frac 3 2 CCT Frac 1 2 CCTT. Which of these terms cause instability in the Crank Nicolson scheme when used for finite volume approach? A. Anti-diffusion term. B. Anti-dispersive term. C. Diffusion term. D. Dispersive term. The correct answer is dispersive term. The stability of the Crank Nicolson scheme for finite volume approach is constrained by A. CFL number. B. Peclet number. C. Time step size. D. Spatial grid size. The correct answer is CFL number. The results using the Crank Nicolson scheme for finite volume approach can be reformulated using the A. Implicit first-order Euler scheme. B. Implicit and explicit first-order Euler schemes. C. Explicit first-order Euler scheme. D. Central difference scheme. The correct answer is implicit and explicit first-order Euler schemes. How many numerical diffusion terms does the second-order upwind Euler scheme have? A. Infinity. B. No diffusion term. C. 1 term. D. 2 terms. The correct answer is no diffusion term. Which of these time steps are used to approximate the value at time step t-Frac delta T2 using the Crank Nicolson scheme for finite volume approach? A. T and Tt. B. T and Tt. C. T and t-Frac delta T2. D. T and t-Frac delta T2. The correct answer is T and Tt. Which of these time steps are needed to approximate the value at time step Frac delta T2 using the second-order upwind Euler scheme for finite volume approach? A. t-Frac delta T2 and T2t. B. T and Tt. C. Tt and T2t. D. T and T2t. The correct answer is Tt and T2t. The numerical dispersion term of the second-order upwind Euler scheme is of A. third order. B. second order. C. first order. D. no dispersion. The correct answer is third order.